All right, so when solving logarithmic equation, I saw you a bunch of ways to do this, right? Depend what you got. So here is the easiest one. You have log on both sides and they have the same base. All you do is make sure the coefficient of log is 1. Then you can just drop both log using the property 10, right? The second one is the second one is when you have log being added and then a number on the other side, then you need to combine the log before you change it into exponential form. And then the third one is you have log everywhere. When you have log everywhere, make sure you combine into a single log. Each side, if you have multiple log on each side, combine into a single log. Coefficient, it has to be 1, and then if you have the same base, you can drop the log. Yeah, that's it. And then now exponential. For exponential equation, the easiest one is the one that you can convert into the same base, and then you can drop the base, right? Oh, I say drop the base, but basically if you take logs to the same base, you cancel them out, right? But you don't have to show me that step. As long as you have the same base, you're allowed to set the power equal to each other. Now, in the case that we cannot make the number into the same base at the other side, then you have to use log, right? My favorite is I'm just gonna use log at the same base as the number that have x in it. That one. If it's 4 to the x, I'll use log space 4. If it's pi to the x, I use log space pi, right? So depend what they give you. Or if your calculator does not have log space 3 or log space anything other than 10 or e, you can use log space 10. Log space 10 always work for any problem. You just have to do a little bit extra, right? You have to go through the power rule stuff. Okay, so let's do this one. Number 3. What do you think I'm gonna take log base what on both sides? I need to, E, right? Log base E, which is ln, right? So what I'm going to do is I'm going to add ln both sides. Or you can do log space E, doesn't matter. Right, so it's what I do. No, same thing. Log space E and ln are the same thing. I just like ln because I have to write less. ln and then 24. What's ln E equal? 1, right? So 2x, drop down. Read that little parenthesis. So you say this one is 1. So it's just 2x equal ln of 24. Now, on the right hand side, you cannot drop ln, right? Because that's ln of 24, it's not ln E. A lot of people, they do this, write this down. A lot of people, they do this. They kind of drop on the right, which is correct. And then they do the same thing on the, I'm sorry, they simplify on the left, which is correct. And then they do the same thing on the right. But we don't have E here. We don't have E. So we're gonna keep that ln of 24. It's kind of like square root of something, right? How do I solve for x? Divide both sides by 2, right? Divide both sides by 2, which is x equal ln of 24, all of that over 2. And please do not cancel the 24 and the 2. They are two different things. The 24 is being connected to the ln, right? If in front of ln, then you say 24 times ln, but here is ln of, right? ln of. It's part of ln, cannot cancel. If I ask you to route it to 4 decimal places, you plug in your calculator. So ln of 24, make sure you go out of the parentheses there, don't divide it by 2, 1.5890. 1.5890. Okay, so far so good? Yeah. Why don't you try number 4 for me? Hi, Corey. Hi, Devin. Oh, no, you have to subtract 2 first.
Oh, yeah.
I forgot to tell you guys that you only take one whole side. They are single. Subtract 2 first. Anybody got an answer or something? Okay, let's see. Yeah. Okay. All right. I got you. Gonna subtract 2. Do not take ln right away. So you don't have to write this down. The reason we don't, if somebody don't write this down. If people do this, it's wrong because we don't have addition rule for log. Remember, addition becomes what, multiplication, right? And vice versa. But we don't have addition, so we cannot do that. Okay. So so e to the x plus 1 equal 14. Now we can take ln. And so I have x plus 1 equal 14, x equal 13. Oh, you know what? No. ln 4. I forgot ln. Yeah, ln 4 equal minus 1. I just did the same thing that I told Sue not to do. I canceled the ln on the right as well. Subtract 1, so x equal ln 14 minus 1. Yeah. And you, if you want, you can give me decimal if I ask you to. But I always want the exact answer first. I always want this guy first. Okay. All right. Now we're gonna use some application for log and exponential models. Do you guys remember compound interest? I taught you this, right? Yeah. So the first one is we use when what? When do we use this? When it compound how many times? N time, right? Yeah, N time. Depend. If they say annually, you say 1 time, semi-annual 2 times, monthly 12 times, etc. And the second formula, PERT, we use it when we compound how many times? Yeah, continuously. You keep hitting that enter bar on your computer continuously. You don't have to memorize these. They will be given on the exam, but you just have to know which one to use when, right? I'll give you both formula, but you're gonna choose when you to use it. Now it's more like log. Now exponential growth and decay. Let me remind you about exponential growth and exponential decay. So grow, it go through 0, 1 again, right? 0, 1, and it increasing from left to right, right? So growing like bacteria multiplying, viral video and whatnot. And exponential decay, decrease from left to right, still going through 0, 1. Grow, decay. All Okay, so the formula is I have A equal A naught or A sub 0 times e to the power of kt, where A naught, I call it A naught, you can call it A sub 0 if you want, is the initial amount. It's the very beginning amount. K is the growth or decay rate. This is given. You cannot, well, either given or you calculate it out. I don't want to say given. Sometimes you have to calculate it out, but you don't make those up. T is time and A is your final amount. Okay, all right. Again, I'll give you this. These, all of these, you don't have to memorize all these three formulas. You don't have to memorize. Okay, so let's look at this example. A virus takes 6 days to double its original population. So that means the final amount of virus is double the initial amount, right? How will it take to triple its population? How long will it take to triple its population? So they're asking for what variable here? What variable am I solving ultimately? How long? So T, right? We want T. That's what we want. So let's do a little summary. So I know that the final amount of virus is double the initial amount. And then the virus takes 6 days. So T is 6. By the way, this is different T. And then the one we want is the red T. Double. So how would I write this in math? The final amount is, I'm sorry, triple is 3 times A naught, right? So what we want. Okay, so the formula is A equal A naught e to the kt yeah, go from left to right. Okay, so in order to solve for K, I'm sorry, to solve for T, what do I need? I need K, right? Well, I don't need E. E is just built in. It's just kind of like pi. I need K, I need A, and I need A naught. Well, 3 variables is a lot. How about we just need K? The A and the A naught, we're gonna try to eliminate it, right? So what I'm going to do, I'm going to use what information give me. It say it takes 6 days to double the original population. So I'm gonna replace this A. What do you think I'm gonna replace this A to? Double the initial. So I'm gonna replace that with 2A naught. Yeah. So that's what I told you. Right here, equal, right? And on the right hand side, I'm gonna keep A naught as is. E, and then K, I don't know what's K. Now it takes 6 days to double the original population. So T here should be 6, right? We're talking about the double original population. So we use all the information from that sentence. Can I cancel A naught both sides if I divide both sides by A naught? Like that, right? Cancel. And now I have 2 equal E to the K times 6 is the same thing as 6 times K. How do I solve for that? How do I solve for K? Step 1, find K. ln, right? ln both sides. Because I need to get rid of that E. So on the left hand side is ln 2. On the right hand side, ln E is 1. So it's just 6K. Divide both sides by 6. And please do not cancel the 6 with 2. K equal ln of 2 over 6. I'm gonna keep it like that. I'm not gonna do the approximation because this is not the final answer I'm looking for. So I'm gonna keep it at the exact answer for now. Now step 2, we're gonna find t when the final amount is triple the original amount. That's yeah. Okay, I think it's easy enough, right? We have k, and we can plug in the same thing again. I have a. My a look weird. A equal a naught e to the kt, and just rewrite the formula there. And I'm gonna replace a with 3 a naught, kind of like I did on the other step. Keep it red. And on the right hand side, a naught remain as a naught. E, now I have k, right? So I'm gonna replace k with ln 2 over 6. T is what I'm looking for, times t. Do you have any question up to this point? Do you guys see the pattern here? First, I need k, right? Because my final answer is t. So the first step, I was looking for k using the first information. The second step, using the second information to solve for t. Cancel a naught both sides like we did. Why don't you guys solve that? I'll see what you have. Why don't you solve that one? There are some announcement I need to it's important announcement. It's about final exam date. I need to announce today. I hope everybody here. Yeah, I need to announce today. Anyone? Anything? Okay, then. ln of 2 over 6 is just a number. So you can multiply both sides by 6 over ln of 2. Yeah. So, okay. All right, everybody gets stuck at the same thing. People from Zoom, do you guys get the answer? And then ln, that's become 1. So I got ln of 3 equal ln of 2 over 6 times t. All right. Okay, now ln of 2 over 6 is just a number. If you plug in your calculator, it'll give you some kind of decimal, right? So I want to treat it as like a over b. If you want to get rid of a over b on the right hand side, what do you multiply both sides with? B over a, right? So I'm going to multiply both sides with 6 over ln of 2. So that on the right hand side, cancel. Cancel. That and that cancel, right? So on the left hand side, it's going to be ln of 3 times 6. You know what? I'm going to put the 6 in front. I don't like the 6 next to the 3. Yeah, 6 over ln of 2. How that? Times ln of 3. Equal t. And you plug in your calculator, right? So roughly t is roughly see, 6 ln of, was it 3 or 2? 3 divided by 2, ln of 2. I got 9.5, roughly 9.5 days, right? The answer makes sense. It's getting short. The more virus, it takes shorter time to multiply, right? It's exponential function right there. Make sure you put units, which is days. I wonder if I can show you on the, yeah, I wonder I can show you. Right. Yeah, I'm gonna try, see if I can show you on a decimal. Okay. What? Can you guys see my screen? Yeah. See if I can show on decimal how fast the virus goes. We got the right answer, just play around with it a bit more. So I got y will be your final amount equal a naught. Wonder if I can do a, and then e to the k is gonna be ln. Was it ln something? ln 2/6. By 6, and then t is the variable that you're looking for. All right, slide it for a and for t as well. Oh, okay. All right. So a, let's say 10 virus. Oh, sorry. I need to move this out. Wait. Where's my function? All right. Okay. Why is it? Well, let's do t. T is okay. This should be you know, I'm gonna pick one for a. I'm gonna pick an a. Yeah, I'll pick a as initial amount will be I have 100 virus. Maybe I should do 100. Because when it's equal to 0, 1, maybe 10 virus, maybe. Okay. E to the, all right. I'm still not happy with the way it, why is it straight line? It's the exponential. There you go. It doesn't like t. All right, I'll use x. Okay, does not like t. Equal. How do I make this? Oh, right. I don't have to. I'm sorry. I just can click on the thing. Right. So I just randomly pick a initial amount, which is 10 virus. Right. So you have 0, 10 right there, right, as your initial point. And then in 6 days, what happened in 6 days? When x equals 6, what happened? X equals 6 days. We can do this. when x equals 6, what happened? There's 20 virus, right? What about 9.5 day? 0.5. 30 virus, right? Or 30 virus. So it's triple from 10 to 30, right? It tripled the amount. So we know that we're doing the right thing. Does that make sense? We're saying in T days, it's triple the amount, which we proved it right. 9.5, triple the amount. 9.5 something, so this number should be close to 30 more if you put more digits in it. All right. Hi, Corey. Got it. Screen. I'm sorry, Curtis. Curtis, say hi to Corey twice. All right, second one is about carbon dating. So this one is exponential decay, right? Carbon 14 is used for archaeology. How do I say it? Archaeological? Okay, archaeological carbon dating. Its half-life is 5,730 years. Wow. How much if 100 grams sample of carbon 14 will be left in 1,000 years? All right, so how much of a 100 gram sample of carbon 14 will be left in 1,000 years? So what they're asking, remember, let me write out the formula. A equal A naught, which is the initial amount, times E, which is just some transcendental number, to the KT. So it's asking for what? It's asking for which letter here that I'm looking for. Let me summarize a little bit. I know that A naught is 100 gram, right? Let's say 100 gram of sample, so that's initial amount. The amount of half-life, the amount of half-life, the T of half-life first. So its half-life is 5,730 years. What does that mean? What does that mean? So every 5,730 years, the initial amount reduced to half. And if another 5,730 years, it reduced to another half. Right? So it's kind of like that. It's go every roughly 5,700 years, it's reduced to half of what it had. So after one time, after 5,730 years, how much A of half-life do I have? From 100 should be what? Go down to 50 grams, right? That's what I said. Every half-life is reduced to half of the amount. Every 5,730 years. Okay, so I don't know K. K don't know. But I need to find what? How much of 100 gram sample of carbon 14 will be left? So I need A, right? I need the final amount. And then when T is 1,000 years, Okay, so first, same thing like here, we need to find K, right? We need to find K. A, let me rewrite the thing. A equal, keep moving. A equal A naught times E to the KT. I'm gonna use this information right here to find K, right? So instead of A, I'm gonna replace with A half-life, which is 50 grams. And A naught is 100, that's the initial amount. E is just E. K, I don't know, that's what I'm looking for. And T is half-life, so we're talking about half-life, so it's gonna be 5,730 years. And then you solve for K. What do you think the next step I'm going to do? Divide both side by 100. Right. I need E all by itself before I take ln. So, I'm gonna use red. I'll leave it blue. No, you read. I keep it consistent with what I had. Step number 1. Okay. All right. K is what is so 50 divided by 100 is half, equal, makes sense, half life. So half, and then e to the k times 5,730. Take ln both sides. Every time you see e, take ln both sides. On the left hand side, it's just ln half. Instead of half, I'm gonna write 0.5 here. Just save space. On the right hand side, ln and e cancel, which is 1, right? Which is 1. So k times 5,730, divide both sides by 5,730. Cancel. So k equal what? Can you? I'll leave it like that. I need 0.5 or ln of 0.5 over 5,730. Leave it like don't estimate it, because this is not the final answer. Now step 2, we want to find a. Okay, 5a. Okay. All right. Again, I'm gonna rewrite that formula. A equal a naught e to the kt. A is what I'm looking for. A naught is, again, the initial amount is always 100. You don't change them. E is e. K now I know that it's ln 0.5 over 5,730. And I forgot to do this in red. And T is T. T is what? T is 1,000, right? After 1,000 years. So T is 1,000. Why don't you? I'll show you how to plug in your calculator. Okay. All right, get your calculator out, plug it in. 100. Do you guys know where E is? In that little division side right there. So second division is E. 2K is, I'm gonna do fraction. So alpha, the green one, alpha frac, ln 0.5. The bottom is 5,730. T is 1,000. Something wrong. Hang on. Something wrong. Oh no. Yeah, something wrong. No. Oh no, nothing wrong. No. It makes sense. I was thinking 10,000 a year. Only 1,000 a year. Okay, it makes sense. 88.61. So roughly 80. No, it makes sense. 88.61 grams. Okay, it makes sense. It makes perfect sense. So every 5,700 years, you reduce to 50 grams. So if it only 1,000 years, it reduces to roughly like 4 grams. It makes sense. As long as your number is between 100 and 50, less than 100 and bigger than 50, you'll be fine. Yay, last one. On the exam, you will have one of these. I'll pick one. And that's how you do it. First, you find K, and then next, you find whatever I'm asking you to find. Right? Number 2, find A. Number 1, I asked you to find T. So it depends. Do you have any question before we take a little break and then move on to 4.1? No. Sorry. You multiply those, break to the power. Oh. Yeah, make sure your answer makes sense so you know that you do something wrong. On the exam, if you got everything correct but your answer is just like really bad, then you tell me like, Mimi, I know I just don't know how to put in your calculator, but this is my answer. Just I'll probably just let it go, right? As long as your work is all correct, it's just the problem you don't know how to do in the calculator, but you should. All right, take a little break. Actually, I'm gonna use this break to say something because it's about the final exam date. Last night I was looking at it back again on the important dates on the OU website. Okay, so the thing is that we not end at August 8 like I thought it would be. It ended August 10. And universities not allow me to let you that doing the final exam between the August 11 like I wanted to. So here, let me put August. So Wednesday, August 10 is our last day. And this day we're gonna do review. And I'm gonna show your grades. You come here and I'll show you my spreadsheet and I'll tell you what you are right now and then how much you got in order to get your whatever you want, right? So I always show students the grade beforehand. Okay, so that being said, our final exam has to be on August 12. I cannot give you on August 11. That's university policy. And I feel bad, this is like the next day. So August 12, 9 a.m. to 11 a.m. This is Friday. Does it conflict with anybody? Anybody have exam on Friday in the morning? Josh, Corey, Devin, Mike, just raise your hand. Just put your hand up and then I know that you're okay. Just put a thumb up. Mike, okay. Josh, okay. Corey, okay. Devin? You okay? All right, yay. Okay, so August 12th on Friday, 9 a.m. to 11 a.m., okay? Maybe in this room. I don't know. I don't know how long it takes for them to fix the other room. And it has to be in person. August 10 is our last day. That's review day. Sorry. I wish I can let you go August 8, but I can't. All right, that's what I want to say. I'll send out an email as well. Okay, 4.1 is totally different animal. It's no longer a law. It's back to solving equation. Now, instead of one equation at a time, we're solving a system of them, like 1, 2, or 3. But let's take one step at a time. Let's do 2 systems at a time. So here is the system of linear equation. AX plus BY equals C, and then DX plus EY equal F. A, B, C, D, E, F are just real coefficient. Let me review this for you before I actually show you some decimal. I'm not gonna make you do this by hand, at least not by graphing by hand. That's my least favorite method to go. A consistent system of equation is a system of equation with at least one solution. So if two equation, a system of equation have at least one solution, we call that consistent. At least one. So either 1, 2, or infinitely many, right? An inconsistent system of equation is a system of equation with no solution. So if no solution, we call that inconsistent. Independent versus dependent. Now, if I give you a linear equation, what kind of graph do you have? Tell me the shape, like curve, straight line. straight line, linear, right? Degree 1, so straight line. So if I give you two linear equations, you see two straight line, right? If your straight line is intersect with each other at once, so it look like, maybe it look like this. You guys can see. Look like this. Then it's independent because the two lines are not on top of one another, right? As long as you can see two lines separately, that's independent. It dependent when the two lines are kind of on top of one another, right? What they call it in the book, I forgot. Overlapping something, I forgot the term they call, but basically it's the same equation. So they kind of lay on top of one another. So that's dependent. Okay, so let me show you in decimals. I do not like to graphing by hand, and I'm not going to test you with the graphing by hand either. But you need to know what is consistent, what is inconsistent, dependent versus independent. Well, as far as solving equation using graphing, this is my least favorite method. Because why? Because when it comes to irrational solution, it's really difficult to pinpoint, right? All right, so let me plug that in. The first one is 3x. Come on. 3x plus y equal -3. Good. And then the second one is 2x plus 3y equal 5. Apparently I have one solution, right, which is -2, 3. Consistent or inconsistent? It has at least one solution. Is consistent or inconsistent? Yeah, consistent. So let me write down here. So solution is -2, 3. Lucky we got integer solution. Do not like irrational solution at all. And then we say inconsistent. I'm sorry, consistent. I'm sorry, consistent. Independent or independent? Independent, right? You can see two lines separately independent. All right, so that's the first one. Let's just do the second one. 2x. Why don't you guys do it? Open your computer. I want you to plug these in your decimals. And you tell me what happened to the rest. Second and third one. You can download a decimal on your phone as well. Equal to x minus 3. Corey, you want to tell me what you got for the middle one? Oh.
Sorry, I just came back. I was printing out the lecture note for this.
Oh, okay, that's fine. Anyone else? Josh, you wanna?
For which one are we supposed to be doing?
Middle one and the third one, the last two. With the system of linear equation. You know what? Mike, why don't you tell me what you got?
Hold on a second. Yeah, I've got a couple of them plugged in, but it's on my phone and I'm watching this on my phone. So I'm like back and forth. So sorry.
Okay, that's fine.
Okay, but you're talking about for B, right? B, 2x minus y equals 1. Yeah, so I've got that plugged in to Desmos, and I saw that as both of those were, hold on a second here. Hold on, which one was I going at here? It was
B.
Yeah, 2x minus y equals 1. Okay, yeah, and sorry, hold on. Because I don't have the notes either. And y equals 2x minus 3. I have that in my phone.
Yeah.
Okay, and those are independent because they're not touching.
Good.
And yeah, what was the question? Sorry.
Is it consistent or inconsistent?
I don't know how to determine that. I mean, it looks like, I mean,
what does it look like? What does it look like?
Yeah, it's a linear equation. Like there's a line. So yeah, I guess it's
how many
consistent.
lines?
There's a solution, right? Yeah.
How many lines do you see?
I see 2 lines.
Okay.
Well, what is it? One for each equation. So at least one answer, right? So.
Okay. The 2 line, how does it position? How does it possess itself?
They're parallel to each other, and they're going, I guess it's straight. It's going upward.
Like that. Okay. So
yeah.
Now here I don't care how it go or down, up or horizontal. What I'm looking for is either does it have solution. Now, if I have 2 lines that kind of go parallel to each other, go on forever like that, do you think at some point they're gonna meet each other? No, right? You go in. No, right? Because I mean, no solution, right? It's like one person on the corner with the other person on maybe 10 mile and 9 mile, right? It's kind of parallel to each other, but never meet each other if you don't take intersect, right? So
now I'm getting it. Okay.
So because it's parallel, so solution is parallel. So that means well, the solution is not parallel. It means no solution. And it's inconsistent because there's no solution. Inconsistent. And it's independent because you see 2 lines separately. Independent. Yeah, as long as you see two of them clearly. Yeah. Huh? No, dependent. Yeah, but they're not on top. They're not, right? On top will be the red with the blue together. Okay. Yeah. Here, that's the third one. What you got? Third one for Curtis. You wanna? Let's see. Yeah. Yeah, because I mean they kind of overlapping, right?
Yeah. So would it be?
Yeah, it's dependent, right? The dependent. Is there a solution? What solution mean? Solution mean 2 lines, they touch each other, right?
Yeah.
Here a lot of touching here, right? It's infinitely many solution, right? So it's infinitely many solution. So solution is infinitely many. Infinitely many. I'll show you what I wrote. Is consistent or inconsistent? Yeah, because at least one solution. In this case, a lot of solution. Consistent. If I don't know how to pronounce it right. That's okay. Thank you for your input. You're not supposed to know this, like professional, understand this like well. I'm supposed to teach you, but I just want to know how much you know. All right, so let me show you something. Y is what happened if it one solution, what happened if it no solution, what happened if it infinitely many solution. What do them look like in terms of algebraic, you know, perspective. Start share, yes. Okay, so the first one is we say one solution. If you look at the equation, and if you solve for y, I'm just gonna solve for y for the first one here. I'll use green. Let me solve for y. So here y equal negative 3x minus 3. And the second one, if I solve for y equal negative 2/3 x plus 5/3. You don't have to know how to say. If you look at the slope, are they the same? Different, right? One is negative 3, the other one is negative 2/3. So the slope different. What about the y-intercept? What about b? Y equal mx plus b. So what is about b? Also different, right? So if you have a different slope, different y-intercept, then it's pretty sure that you have one solution. So here you have different slope. Maybe I'll say it here. I'll save in my time. Y equal I'm just y equal mx plus b here. M is different. B is different. What about the second one? Let me solve for the second one, see what happened. Y equal 2x minus 1. And here, this one is y equal 2x minus 3. Look at the slope. They have the same slope, right? But what about the y-intercept? Y-intercept is different. So if you have a same slope, different y-intercept, then the two lines are parallel, which is makes sense. All you do is just shift, right? All you do is just shift. If you look at the third one, third system equation, can someone tell me what do you see? There's something about the third, the first and the second. I'm talking about the third one. The second one is triple the first one, right? So basically the same thing. All you do is just extend it in length, right? So they must have the same slope and same y-intercept. If you solve them out, they will have the same. So makes sense. If you have the same slope, same y-intercept, you do the same thing, right? Same. It's kind of like twin. So also same. All right. So you need to know these. You don't have. I'm not gonna ask you to grab by hand. Never ever. At least for not these type of thing. Waste of time. My favorite is solving by substitution or elimination using algebra. Right. So on the exam, you expect something like these. But I'm gonna ask you whether it's consistent or inconsistent and whatnot. All right, solving system of equation by substitution. Like the name suggests, substitution means you substitute something into something, right? Let me show you the first one. If I was you, I want to substitute y, right? Because I see y all by itself here. The coefficient is 1, is perfect when you solve for y. So let's solve for y for this one. Y equal negative 2x minus 4, right? And what I'm going to do, I'm going to put that negative 2x minus 4 for y into the second equation. So second equation is this one. 3x minus 2 times, instead of y is going to be negative 2x minus 4 equal negative 6. You guys know how to solve for this, right? So it's going to be 3x plus 4x plus 8 equal negative 6. Combine like term, 3x plus 4x is 7x plus 8 equal negative 6. Subtract 8 both sides. 7x equal negative 14. X equal negative 2. And don't stop. You need to solve for y, right? So what you're going to do is you're going to put negative 2 back here and then solve. Negative 2 times negative 2 minus 4. 0. Oh, 0. Okay, so your solution is going to be negative 2 comma 0. You know what I'm going to do on the exam? For this part, maybe I'll give you a graph. And then I'll ask you whether it's consistent or independent. Okay. And it's the solution. It's kind of like what we did here, but instead of system equation, I'll give you a graph and you tell me what happened. All right, why don't you guys try this one and then we'll call it a day. X is already solved for, so I would use that. I wouldn't solve for Y. Actually, maybe we can try a few more. But I want you to finish 4.1 so you can do your homework. Anyone have answer? A little fast. Is that what you have? You can do different than I do. You can solve for Y first, and then you plug it. It doesn't matter to me. Some people like to solve for Y in the first equation, and then they plug it back into the second one. That's fine, it's not wrong. But your solution should have the same as mine. Did I At the end, I do like you to put it in order pair as well. Okay, the second one is solving by elimination. I use this all the time. Like literally, if I don't have like y or x solved for me, then I literally use this like all the time. So elimination, like the name suggests, you want to eliminate one of the variable. So pick one. Pick your least favorite of the two, eliminate them, and then solve for the other. Now, for me, I'm going to pick one that I can easily eliminate. Here, I see y is easier to eliminate at first than x, right? So the coefficient of the second y is what? -1, right? So all I have to do is I'm going to multiply both sides for the second equation by 2. So this become, I'm going to rewrite the first equation, just use 5x plus 2y equal 2. And the second equation is everything double. So -6x minus 2y equal 0. And now, because I need to eliminate y, right? I'm gonna add the two equations together. That's cancel. Now we only have one variable, right? 5x minus 6x. So, oh, by the way, you always add, okay? Always add. So -x equal 2 plus 0 is 2. So x equal 2. And then you plug it back. Pick one equation, the original equation, pick one. And then you solve for y. I'm going to pick the second one because the second one seems easier. So -3, x is 2 here, minus y equals 0. Okay. -6 minus y equals 0, y equal -6. So 2 comma -6. If you want to check your solution, all you do is what? Plug them back into the, both of them, though. You have to do both. And if they equal to 2 and then equal to 0, then you're okay. Okay, so let me see. If it equal to 0 and 2. X is 2, y -6. 10. Yeah, my bad. Thank you. I'm glad we check. -2. And then -2. So 6, +6, right? Yeah. Thank you very much. Okay. Yay. All right. Check. -10 plus 12 is 2. Yay. And then the second one, -3 times -2 is +6. -6 is 0. Yeah. It had to be both. Both had to satisfy. If one of them is not satisfied, then you got the wrong solution. Second one. Ooh, this one is an easy one. You tell me which variable you like to eliminate. Just pick one for me and I'll do it. First one, so multiply first one by. Which variable though, x or y? I don't think it's matter in this case. Sure, yeah, y. So multiply both sides by 2, right? Because I need -10, right? In order to eliminate y. So multiply both sides by 2. It's already opposite. So here I have -6x minus 10y equal -18. Rewrite the bottom one, 6x plus 10y equal 1. And now you add. Oh, look at that. On the left-hand side, just 0. X and y cancel out. On the right-hand side is -17. Is this true? This is true. 0 equal -17. No, not in our universe, right? So not possible. Or you say false statement, false. So therefore, the system have no solution. So what does it look like if you graph these two guys? two, no, one line means you have a lot of solution. The two line, right? Yeah, think about 10 mile and 9 mile parallel, right? Never meet each other. If you want a fancy, you can write like this. Do anyone know what that is? That little zero and then have a cross. Empty set. Empty set. If you want to, so empty set. No solution. Curtis, if you do engineering, you probably see it again. Right? A lot of professors, they do this in higher course. So give me one, doesn't matter which one. Okay, so I'm gonna stop here. I want you to do this at home. But now you can finish your homework. Okay, finish your homework. I think we have infinitely many solutions here now. I don't remember, but do that at home. Pick the method of your choice. All right, thank you for bearing with me. Do you have any questions? Okay.
I was going through like trying to put in things and it like ended because we like.
Oh, you add it. Oh no, not add another sheet. Add another date.
Yeah, but it's at the end because it's meant to like go all the way to.
No, you can. Yeah, you can do like this. And then insert column to the right. Yeah,
you could do that.
Yeah,
okay.
yeah. Don't add another sheet.
Okay.
But thank you so much. Yeah, just keep doing it for me, so you guys know be able to edit.